Welcome to the DIY Off-Grid channel, guys. I'm your host, Rancher Pete, and today we're breaking down the economics of driving electric vehicles, gas cars, and hydrogen fuel cell cars. Over the last few days, we've been doing a deeper dive on how green renewable energy systems are and the correlation between solar panels, lithium batteries, and carbon emissions. Today, I wanted to go through the economics of renewables in the context of cars, as utility bills and cars are among the two biggest drains on our pocketbooks every month. Let's dive into the numbers to uncover which options give you the most bang for your buck and how they compare purely in terms of cost per mile driven. Now, I won't get too deeply into the cost difference between electric cars and internal combustion engine vehicles because, well, it's not really clear cut to do a one-to-one comparison. There are just far too many factors and nuances that make it rather difficult to compare, and subsidies and tax credits can impact prices quite a bit. So again, we're not going to look at the initial acquisition costs. Same with hydrogen fuel cell vehicles as well. There aren't that many out there to compare with to begin with, but our goal today is to look strictly at the cost per mile driven. Now, let's start off with gas cars first. We'll disregard diesel as essentially being phased out for passenger vehicles in the United States. The price of gasoline ranges from as little as about $2.50 per gallon in Oklahoma to around $4.50 a gallon in states like California and Hawaii. The national average for gasoline-powered vehicles is right around 25 miles per gallon, but obviously that can range from less than 15 miles per gallon to just over 50 miles per gallon. At 25 miles per gallon, the cost per mile ranges from about 10 cents to 18 cents per mile between Oklahoma and Hawaii, but can be half that for a car with 50 miles per gallon, 5 to 9 cents per mile, and double that at 12.5 miles per gallon at 20 to 36 cents per mile. Next up are hydrogen fuel cell vehicles, another topic that comes up regularly on our late night live streams. Now, as an engineer, I've always wanted to see hydrogen fuel cell vehicles commercialize and succeed, but with the pace of development on the EV front, and I'll be very frank, I don't see any likelihood of hydrogen fuel cell vehicles ever succeeding, at least in the realm of the passenger vehicle market. There are just far too many compromises, the costs are exorbitant, and they're just far too complex to realistically bring down the cost. At the moment, the average cost of hydrogen per kilogram is about $30, and all the fuel stations are exclusively located in California. There are only 3 models that are currently available: the Honda CR-V FCEV, Hyundai's Nexo, and Toyota's second generation Mirai. They average roughly about 70 miles per kilogram, which at current prices is 43 cents per mile. Now, hydrogen prices are rather absurd here, as it's just $8 per kilogram in Korea and Japan, where gasoline is more expensive than it is in Hawaii. So just for context, it would cost just 11 cents per mile to operate these vehicles in those countries. Lastly, let's look at the cost per mile for EVs. As I pointed out yesterday, the beauty of electric cars is if you have a solar setup and you charge at home, the cost per mile could be essentially free. If we suppose very low cost supplemented with solar, say 5 cents per kilowatt hour, the average EV that gets 3 miles per kilowatt hour would cost just 1.7 cents per mile to drive. And at the opposite extreme, California's ridiculous 40 cents per kilowatt hour rates, it would be just over 13 cents per mile. At the national average of 17 cents per kilowatt hour, that same EV would cost just 5.7 cents per mile to operate. A more efficient EV that gets over 4 miles per kilowatt hour, the low end would be just 1.2 cents per mile to 10 cents per mile in California. And the current EV pickup trucks out there that average 2 miles per kilowatt hour would cost 2.5 cents to 20 cents per mile to operate. Let's take a look at what the cost per year would look like. At the national average cost per gallon for gas with the national average fuel economy vehicle, driving 15,000 miles a year would cost $1,800 per year. A hydrogen fuel cell vehicle at the current cost of hydrogen would cost $6,500 a year to drive the same distance, nearly 4 times as much. On the other hand, an average BEV at the national average cost of 17 cents per kilowatt would cost just $850 to drive the same distance, a little less than half the cost of a gas car. On the maintenance front, EVs cost quite a bit less per mile compared to ICE cars in general. The DOE, Argonne National Laboratory, and the GSA have conducted studies, and the results show the cost of operating EVs to be about 40% lower per mile than internal combustion engine vehicles, at just 6 cents per mile compared to over 10 cents per mile. Now, I couldn't find enough data on fuel cell vehicles, and with the availability of fueling stations limited to just under 60 locations, all within California, I'm pretty sure none of my viewers have ever seriously considered getting a hydrogen fuel cell vehicle. Now, I'm not here to suggest to my viewers to go out there and get an electric car by any means. We're just here to look at the different scenarios and cost and discuss the fact that, again, unlike vehicles that require fuel, electricity is something that you can produce at home for cheap. If we consider the fact that nearly 80% of all the crude oil in the United States is used for transportation, and some 91% of all the gasoline consumption is for light-duty passenger vehicles, SUVs, and pickup trucks, it's certainly a quick and easy way to address our tremendous appetite for crude oil in this country, which amounts to some 20 to 21 million barrels per day, or around 850 million gallons per day. Now, electric vehicles are the clear winner for cost savings, particularly in areas with affordable electricity. While gasoline cars remain a viable option for upfront affordability, their higher running costs make them more expensive in the long run. Hydrogen cars, on the other hand, while promising, need more infrastructure and price reductions to really have any chance of being competitive. As we transition to a cleaner, more sustainable future, I think EVs offer a compelling balance of affordability and environmental benefits. Now, over the next few sessions, we'll talk a bit more about the different battery chemistries, availability and sustainability of the materials, and get into some more facts about the energy density of the different fuels, so you can have a better understanding of where we are with these technologies today and where we're headed. So again, thank you for tuning in to the DIY Off-Grid channel today. If you found this breakdown helpful, don't forget to subscribe and share and tap that like button. Have questions or topics you'd like us to cover, leave a comment or message me directly. Until next time, drive smart and stay green.